Good morning, students. Once again, I welcome you to my video lectures on GATE class. This is my second episode. Now, today I will solve problem from 2022 IT paper. 2022 IT Instrumentation Technology. Given circuit A with currents I1 and I2, the current I3 in circuit B is dash. So this is circuit A, this is circuit B. If you closely look into these two circuits, circuit A and circuit B, there is one unknown in these two, that is R0. So R0 resistor value is not given, and that is why instead of one circuit we have two circuits. So this is one circuit, this is another circuit. So from this circuit we have to find R0. We have to find R0. So first I will find R0 from circuit A, then I will explain how to find I3. So ultimately we have to find I3. So I1 and I2 are the two currents in circuit A given. I1 is 2 amperes and I2 is 1 by 3 amperes. So we have to find I3. Now first concentrate on circuit A. Circuit A, if you concentrate, so we have to find R0. Now if you look into this circuit, 2 amperes. Now you mark currents in all the branches by applying KCL. So to mark currents in all the branches, so first I will mark this current as X. So this is X. So now this current becomes 2 minus X. 2 minus X. 2 minus X. And this current is I2. This current is I2. Therefore, this current is 2 minus X minus I2. 2 minus X minus I2. First 2 amperes, a current X ampere. Therefore 2 minus X here, 2 minus X and minus I2. So what is I2? I2 is 1 by 3. Therefore this current is 2 minus X minus 1 by 3. Minus 1 by 3. So 2 minus 1 by 3, that is 5 by 3. That is 5 by 3. Therefore this current is 5 by 3 minus X. 5 by 3 minus X. 5 by 3 minus X. Now 5 by 3 minus X. Now apply KVL to two separate paths. So first I will apply KVL to this path. To this path, and another path I will take this one. Now I will apply KVL to this path. If you apply KVL to this path, then 2 into R0 plus 4 into 2 minus X, 4 into 2 minus X, 4 into 2 minus X, next plus 8 plus R0, 8 plus R0, 8 plus R0, 8 plus R0 into 1 by 3, into 1 by 3, 2 R0 plus 4 into 2 minus X plus 8 plus R0 into 1 by 3 and equal to minus 16 equal to 0. Because you have to come this way. Minus 16 equal to 0. This is one equation. This is one equation. Second equation is I will take this part. R0 into 2. r naught into 2 plus 8 into x plus 8 into x plus 8 into x next equal to 16 or minus 16 equal to 0. Minus 16 equal to 0. So this is equation number 2. So first apply KVL to this path, then apply KVL to this path. So we are going to get two equations. Now I will manipulate these two equations. Now if you manipulate these two equations, you will get (16 by 3) equal to 7 by 3 r naught minus 4x. 16 equal to 2 r naught plus 8x. After manipulation, I am getting these two equations. If you solve simultaneous equations, these two equations, you will going to get r naught as 4 ohms. I am not solving simultaneous equations. You solve simultaneous equations and r naught comes out to be 4 ohms. Now I have found out the value of r naught, which I will go to substitute here. 4, here also 4 ohms. Next, having found out the value of r naught as 4 ohms, so next comes the question, what is I3? While studying network analysis, your teacher might have taught you what is known as writing directly KVL equations by what is known as inspection method. Inspection method is a method of writing KVL equations directly looking into the figure. Because if you don't apply this method, then it will be very tedious to write KVL equations. Therefore, you are supposed to know a technique called inspection method. So by inspection method, you can write KVL equations directly. Now I will explain that point, how to write the equations by inspection method. Now, first look into this circuit. So how many meshes are there? 3. 1, 2, 3. Now I will take meshes in these directions. Already I3 is given, therefore I will call this mesh as I3. Next, I will call this mesh as X. Next, I will call this mesh as Y. So how many meshes are there? 1, 2, 3. 3 meshes. So 3 meshes means 3 equations. So 3 equations, 3 unknowns, 3. I3, X, Y are the 3 unknowns. Now if you write the KVL equations, it will be like this. It will look like this. This is resistance matrix. This is current matrix. And this is voltage matrix. Now I will explain. I will write by inspection method this matrix. This is called as resistance matrix because this is a DC circuit. In AC circuits it becomes impedance matrix. Now first, there are 3 elements in each row and 3 columns, and here I3 XY. Now I will fill up the resistance matrix. So first I will complete the matrix, then I will explain. 4 plus 8, 12. 4 plus 8, 12. Next, second matrix, 4 plus 6 plus 8, 18. 8 plus 4 plus 6, 12 plus 6, 18. 18. Next, resistance common to mesh I3 and mesh X. This one. This one is common to these two meshes is 8. 8. I will take with minus sign. I will explain why I took this with minus sign. Next, here also I will write it as minus 8. Minus 8. Next, resistance common to mesh 2 and mesh 3. Resistance common to mesh 2 and mesh 3 is 6. 6. So here you take this as minus 6 and also take this as minus 6. Minus 6. And next, to fill these two, resistance common to mesh 1 and mesh 3. No resistance common. Therefore, 0, 0, 0. Next, I will complete this. So, total voltage in mesh 1, 8 volts. 8 volts is driving current in this direction only. Therefore, take this with 8. So, this is plus 8 because this 8 volts is driving this mesh current I3 like this. Therefore, it is taken with plus sign. Next, second mesh, no voltage sources. Therefore, no voltage sources, 0. 0. Then third one, the mesh current is like this, but this is positive. So positive 48 volts tries to drive in other direction. Therefore, take this with minus sign. Minus 48. Now once again I will explain this matrix, how to write the resistance matrix by inspection method. First, what is this element? This element is in first row, first column. First row, first column. The diagonal elements are called R11, R11. Here, second one is R21 and third one R31. That is 1 suffix stands for element in first row, first column. Second row, first column. Third row, first column. So this diagonal elements are always taken with positive sign. They are called as self-resistances. Self-resistance means total resistance in the respective meshes. So in this mesh, total resistance is 4 plus 8. 4 plus 8. Therefore, 4 plus 8 is 12. Next, second one. These diagonal elements are always taken with plus sign. Second one, R21. R21 means resistance, self-resistance of mesh 2. Mesh 2. Sorry, R11, R22, R33. Sorry, I made a small mistake. Diagonal elements are R11, R22, R33. So next, R22 means total resistance in mesh 2. 4 plus 6 plus 8, that is 18. Take with plus sign. Next, R33, resistance in mesh 3. Total resistance in mesh 3. 8 plus 4 plus 6, that is 18. So diagonal elements are always taken with plus signs. The other elements are called as mutual resistances. That means this element, minus 8. So minus 8 is in first row, second column. First row, second column, R12. Now you take R12 same as R21. You reverse the subscript. Then R12 becomes R21. Now comes the question, should we take R12 or R21 with the plus sign or minus sign? So now look into the condition here. 8 ohms is common to mesh 1 and mesh 2. And in this 8 ohms, the two mesh currents are in opposite direction. So I3 is like this, X is like this. So when the mesh currents are opposite, take with minus sign. That is why here I have taken the current with minus sign. First row, second column element, is same as second row first element, second row first column element, that is R12 is equal to R21. R12, this is R12, same as R21 minus 8. Next, coming to R23 equal to R32. Coming to R23 equal to R32. So resistance common to second mesh and third mesh. Second mesh and third mesh, the resistance here is 6 ohms. Here also through 6 the mesh currents are in opposite directions. Therefore, R23 is equal to R32 is equal to minus 6. So that is why here I have taken minus 6 minus 6. Now next, coming to mesh 1 and mesh 3, that is R13 equal to R31. There is no resistance common to mesh 1 and mesh 3. Therefore, it is 0, 0, 0, 0. So having completed the matrix, this is resistance matrix, this is current matrix, and this is voltage matrix, and I have already explained how to take the numbers with this plus sign or minus sign. Now we have to solve for I3. Now what is I3? You have studied determinant. Therefore I3 is matrix, determinant 8 0 minus 8. Next, minus 8 18 minus 6 0 minus 6 18 divided by delta, which is equal to determinant 12 minus 8 0 minus 8 18 minus 6 0 minus 6 18. Now if you solve, now one thing, use calculator. I think in the examination you are permitted to use ordinary calculator. So now, or scientific calculator. Now solve for I3. So I3 comes out to be 0 amperes. I3 comes out to be 0 amperes. So use calculator to solve for I3, and I3 comes out to be 0. So this is how the answer is 0. The answer is 0. So in this paper, there are two, in this question, there are two networks. So from network A, you solve for R0, and in network B, you solve for I3, and I3 comes out to be 0. Thank you.